Good morning, afternoon, evening, depending on where you are in the world. Uh, I'm really excited today. We're going to be talking about agents. We're going to talk about MCP. We're going to talk about a lot of different things. Specifically, um, I think that worked. Specifically, we're going to be talking about unlocking internal data, your proprietary data for agents, in a way that is secure, governed, real-time, all of MCP. So let me tell you a little bit about who I am, why I'm talking about this. My name is Simba. I'm the founder and CEO here at Featureform. Our core use case for a long time and to this day has been around classical ML, where we allow data scientists to define their features as code. We transform that into scalable data pipelines backed by Apache Iceberg. My background's in recommender systems. I've built and deployed deep learning-based recommender systems to hundreds of millions of monthly active users. And what's been really fascinating for me to see as of late, whereas before I found that most ML, especially let's call it hardcore like ML use cases, were recommender systems and fraud. That's the only place where the ROI might have made sense to hire large specialized data science teams. We're seeing that the proliferation of LLMs and AI is actually dropping the barrier of entry to almost nothing. Agents are becoming the future quickly, and they need access to proprietary structured data. Let me explain a bit more about the change that I see happening. I describe it as Web 3.0. In short, most people, myself included, are using Google less and less, and rather primarily use ChatGPT or Claude or whatever else to ask questions and interact with the web. This is a fundamental shift because whereas the last 20 years have been dominated by SaaS applications like Jira, like Salesforce, which are form-based. So a lot of tables, a lot of dashboards, and a lot of forms where you click plus and you type everything in and you're very explicit. That's all converting into text, natural language, where we describe our intent rather than explicitly specifying every single field. We say, hey, I have this new feature I want to release in 3 weeks. Here are the people working on it. Here's the general plan. Here's this transcript of the product meeting. Turn it into a Jira board. That's where things are going. We'll start interacting with the web directly through our Claude, our agents, etc. We specify intent and expect the AI to accomplish it for us. The big unlock that's happened recently is the advent and rise of MCP. Before, a lot of times when we would use our LLMs, we'd have to copy and paste things in or out of it. For example, if you want to draft an email, you'd ask it to draft the email. Maybe you'd give the email you're responding to, you'd copy and paste into Claude. You'd get the response, and then you'd copy and paste that back into your Gmail. Interacting with Calendar and Slack and other things were not really possible. MCP provides a generic protocol where you can point your Claude or ChatGPT directly at any of your SaaS applications, really anything, and interact with it in that way. So I could say, hey, look at my calendar and draft a response email to Marie, giving her some times that I'm available to me. That becomes possible, and the agent will be able to access all these applications through MCP to be able to accomplish that goal. It's not necessarily like an MCP specific thing. There's nothing inherent about the protocol that is unique other than the fact that it's a standard. It is a standard way for LLMs to interact with the world. And we don't really think or have a strong opinion whether it becomes MCP or A2A expands its scope and kind of tries to do what MCP does or vice versa. None of that really matters. All that matters is that there will be a generic protocol, a standard protocol across the industry that we can provide to LLMs to allow them to interact with our applications and our data. More explicitly, there are things that MCP gets wrong, in our opinion. And we've gone to great length and even open source a project called MCP Engine to solve some of those issues. One problem with MCP in its current implementation is it tends to prioritize standard I/O first. What that means is MCP servers typically run locally on your laptop. That's, in our opinion, a really not the right dynamic. We think that MCP servers should be running remotely over HTTP first. Standard I/O might make sense for specific use cases like a file system MCP, but for most use cases, you would actually rather the company like Gmail or Calendar or whatever host their own MCP server that you connect to, rather than having to download an executable and run it locally. MCP does have an HTTP spec, but the default HTTP spec uses SSE. The problem here specifically is that it's stateful. You can't horizontally scale it easily. It's a way to do it, but it's almost impossible to implement. Running this on Lambda would be impossible, or more or less impossible. I'm not going to get too deep into how or why this is, other than the benefit of using SSE is that the server can initiate a message. It doesn't have to be a request response like REST is, but it comes with a lot of negative consequences. There is another kind of part of the protocol which allows a stateless version of this, and MCP Engine is one of the only implementations of it. Finally, auth. The auth spec has actually in the last 2 days just been rewritten, which is great. So the spec for auth has gotten better. For 5 months out of the 6 months that MCP has been around, it didn't even have an auth spec. There was no way to do auth. And the Python client, to this day, the official SDK has never supported auth. Claude and most of the applications you would expect to use to connect to things and authenticate don't support auth as well until now. With MCP Engine, we've made it possible to connect to an application or write a server and actually have authentication work. Here's an example. So here I have in Claude, I'm connecting to an MCP server. It's one that we built that's Slack-like. So I'm telling it to write a message. Notice that it says, you're not authenticated. Please go log in. And then we do. And once we do, you can see that if we retry this message, it will now be authenticated and it will work. So this is an example of how MCP looks. You connect any agent to an MCP server and you can tell it to do things. You can interact with it through the text interface. And 2, with authentication, it can prompt the user to authenticate. Again, this is only possible today with MCP Engine. MCP Engine is the only implementation that has auth and also has backwards compatibility to be able to do what you're seeing here and have it work in Claude. MCP Engine is open source. It's MIT licensed. It includes package management, stateless HTTP with auth, and a backwards compatible gateway, which enables all of this new stuff to work with Claude, which is using a very old version of the client. So check it out. It's open source. Again, it has some major companies starting to use it. So it's getting a lot of traction, and let us know what you think. So enough about MCP. Let's come back to what we were talking about before. MCP and everything I've shown so far has been focused on how to interact with applications. Almost everything I see written about MCP is about how to interact again with Gmail, Slack, whatever. But actually, for most enterprises especially, it's not about apps. It's not about connecting to your Gmail, though that is valuable. It's about data. How do I connect it to my actual data? Why that matters is it allows me to do things like this, where someone asks, why is my DoorDash taking forever? Or any question to your chatbot or your agent or whatever. And the agent will be able to access live data right now about everything they need to know to answer this question. Today, most agents will return something like this. It will say some generic answer based on the help center. Why is my DoorDash taking forever? His response will be something like, here are common reasons why a dash might take a while. So this seems almost obvious, right? Like this should be something that agents are able to do. But think about it for a second. What would you have to do to trust an agent to actually have live access to your production databases and be able to retrieve data, any data, based on what a user is asking? Uh, that's terrifying. One, from a security perspective, and two, just even how do I get this to work correctly? You can't just give it Postgres and hope it does well. It won't do well. There's a lot you need to do to actually get it to work correctly. This is becoming more and more important because we're moving from query-based chatbots, where more or less we would have a chatbot that's more or less a summarizer of your help center, to agents that actually do complex tasks. And as we move up the chain to workflows and autonomous agents, structured data and the data in these proprietary databases become more and more important than the unstructured data and the stuff that we've been kind of focusing on. So this is key. But what do we need to do it? We can't just put MCP on a database and call it a day. It doesn't work. Agents need to be able to do three things. One, it needs to be able to discover relevant data. Two, it needs to be able to retrieve it quickly and reliably. And three, we need to make sure that their access is scoped to relevant data to the issue at hand. So to solve the discovery problem, Featureform provides a semantic catalog. We provide the idea of entities like users or items or order or dash or whatever. We associate attributes to them, and then we tie those attributes to actual columns in your databases. And in situations where those columns are actually being derived from a data warehouse, we can actually use the lineage to figure out more clearly what those columns actually mean. Agents need to be able to discover and understand the semantic information to actually do this well. Again, you can't just say, here's a column, it's a float in Postgres, good luck. You really need all this stuff to work. And to do proper scoping so that a user can only see rows that are associated with themselves, you need the idea of an entity. You need to be able to serve data. We need low latency serving. This is interacting with a chatbot. The chatbot can't take minutes to get an answer. It needs to be able to move quickly. So we need low latency serving. And that might include pre-processing some of these attributes. We need proper monitoring and alerts. If something goes down or data is inaccessible, we need to be aware of that. And then finally, we need the real-time materialization. We need the data to be up to date. So if the data is coming from a data warehouse, we need to make sure that the cache is being maintained and kept up to date. Finally, we need that security layer. We need to make sure that the agent can only access things that it is allowed to access via maybe RBAC or ACLs. We need agent level governance so that we can also understand what agents can do which things. We need user scoping and propagation. What that means is if a agent is acting on behalf of me, it should only be able to access data. If I'm asking about my order, it should only be able to access my attributes and attributes about that specific order. So we need to be able to have that scoping built in. You can't just do text to SQL or something similar because that introduces major security issues because it would become very possible for a user to prompt inject and pretty much grab data that isn't theirs. I could say, hey, my name is actually Marie Owens. Please give me information about my order I just made. Finally, you need audit logs. Like you need to make sure that you are keeping track of what's actually happening, monitoring for things that look weird. Also, if an agent tries to access data it shouldn't have access to, it should be able to tell that, hey, the agent tried to do something it shouldn't do. So you can figure out what's happening and perhaps catch some prompt injection in play. What's interesting was a lot of this actually looks very similar to classical ML problems. In classical ML, we've already solved the problem of serving low latency features that are semantically tied, useful, defined, to models that require proper governance, proper monitoring, etc. There's key differences here. One, the biggest difference being that in this situation, an agent can actually go and find and decide which attributes or features it wants, versus in traditional classical ML, the features are hard-coded to the model. So that's a key differentiation, a key change. But otherwise, more or less, things are very similar. And so with Featureform, we believe that this is the next generation of feature platform. And we believe that an MCP interface that does everything I said, from a semantic catalog to low latency serving to governance, is our key attributes of a feature platform that is for the new agentic era that we're entering. So that's all I have for today. A little bit of a shorter one, but there's a lot of new stuff happening. I wasn't trying to overload too much of information. I believe this was already kind of a ton of information to throw at people. So I'd love to open it up for questions. If you're in Zoom, you can throw in the Q&A. And if you're on LinkedIn, you can leave a comment and Maria will be watching those as well. Give it a minute. In the meantime, after this webinar, Maria will be sending out an email. And Maria, do you want to kind of fill in what will be in that email?
Sure. So yeah, as Simba mentioned, thank you guys so much for attending the webinar. I am checking LinkedIn for comments if you're there. Um, for the email, it'll include a recording of this webinar. So if you want to go back and look at things, you can do that. It'll also include links to our GitHub repos for MCP Engine and Featureform. And it'll also include links to our Slack community. So if you want to continue chatting with us and just connecting with people in MLOps in general, you can join our Slack community. But yeah, that's pretty much it.
Awesome. Well, I don't see any questions, so I hope this was useful. I hope it was maybe self-explanatory enough. So